Now next is frequency count method. We will take some algorithms and find out how this method is useful for finding the time complexity of algorithms. This algorithm is for finding sum of all the elements in an array. Here is an array. Assume that there is an array of some elements. I have taken an array of size 5 with some elements in it. So what is n? N is 5. So A is this array and n is 5. Now what this algorithm is doing, it is finding the sum of all the elements in an array. Let us analyze the time taken by this algorithm. So how do we do that? By using frequency count method. So the time taken by an algorithm can be known by assigning 1 unit of time for each statement. And if any statement is repeating for some number of times, the frequency of statement, the frequency of execution of that statement will calculate and we find the time taken by that algorithm. So here we have some statement, this is statement which is repeating for some number of times. So we will find out its frequency and that will give us the time taken by this algorithm. So let us see. So this is a simple statement, so this takes 1 unit of time. And as this is C language code for loop I have written, this is C language code. In this one, we know this will execute for 1 time. And this will repeat for n times. But this condition will be checked for n plus 1 time. How? When n is 5, then first time I will be 0. 0 is less than n. When I is 1, 1 is less than n. I is 2, 2 is less than n. I is 3, 3 is also less than n. 4 is also less than n. 5 is not less than n, so it will stop. So I was initially already 0. So how many times I has changed? 5 times. Then how many times this condition is checked? 1, 2, 3, 4, 5, 6 times. 5 plus 1. 4 times it was true and 5th time it was false. When it became 5, it was false, so it has stopped. So this is executing for n plus 1 times. So we say that if you sum up this, this is 2n plus 2, but we write n plus 1. So it means we are bothered about this one only. Right? We are bothered about only this one. We don't want to write about those things. Usually it is written n plus 1 only, but if you observe it carefully, it is 2n plus 2. But we don't want to write the time taken by these two. Right? As I said, we'll be doing it briefly. Then, whatever the statement is there inside this loop, as this is repeating for n times, this statement will also repeat for n times. So this is n times. So now we can understand that whatever is written in a loop, like this type of loop, the statement will execute for n times. And the loop itself, if you take, it will execute for n plus 1 times. Then the last statement, it will execute for 1 time. Then what is the time function? F of n is 2n plus 1, 2, 3. That's it. This is the time function. Now, what is the degree of that polynomial? It is a degree 1. It is just n. So we say order of n. I am calling it as order of. I am not saying big O or theta. We will learn it in some other video. Now, for now, I will say order of n. Space complexity. See, what are the variables used here? A is used, n, s, and I. A, n, s, I. The size of A is n words, and all these are just one word. So total is how much? N plus 3. So that space complexity is S of n is n plus 3. Now this polynomial is also degree n. So we say order space complexity, we got it as order of n, and the time complexity is also order of n. Now, next algorithm is for finding the sum of two matrices. A and B are square matrices of dimension n cross n. N cross n. For example, it is 3 cross 3, then these are matrices or two-dimensional arrays of size 3 by 3. Dimensions are 3 by 3, assuming that. So n by n, they are n by n. Now here I have an algorithm for finding the sum of two matrices. Let us find out the time complexity for this one. For loop, already we know this will take n plus 1 time. Now whatever is there inside this loop will execute for n times. This is n, this is also n. Two lines are there, two statements are there. Each is taking n. Then what is this? Again this is a loop. So for this also n plus 1. Then again whatever is there inside this one will execute for n times. That's it. Now what is the time taken by this one? F of n is n square, 2n square plus n and n, so 2n plus 1. This is the time function for this algorithm. What is the degree? Highest degree? 2. So we don't write degree, we write n square. Order of n square. So we are writing the degree. We are not saying that this is equal to this one. We are saying that degree of this polynomial is n square. That's all. This is the time complexity. Let us take space complexity. What are the variables it is having? A, B, C. A, B, and C. N, I, J. N, I, J. What are A, B, C? They are matrices, two-dimensional arrays, n cross n. N square, n square, n square. What are N, I, J? They are scalar variables, simple variables. One word, one word, one word. So space function is 3n square plus 3. Then what is the degree? N square. So this is also n square. Space complexity is also n square. So the time and the space complexity of this algorithm is n square. How to find the time complexity? I have shown it here. How to find the space complexity? I have shown it here. So for few algorithms I may be showing. For any other algorithm you can find out this one by following this approach. Next algorithm is multiplication of two matrices. You can see that there are three loops nested, one inside another, one inside another. Let us find out the time. On this side I will write, this will be a little far away, so this side I will write so you can see them. This is n plus 1. Whatever is there inside will execute for n times. Every statement n times. Then again this is a loop, so this is n plus 1. Whatever is there inside will execute for n times. So into n, into n, and into n. Then again this is a loop, so this is n plus 1 times. Whatever is there inside will execute for n times again. So as this statement is inside all three loops, so this is going to execute for n cube times. This is inside just these two loops. So this is executing for n square. And these are loops themselves. So that is n plus 1 and this is n square and this is n cube. If you finally write down the time function, f of n will be equals to, see, n cube and one more n cube, 2n cube plus, this is n square and this n square and this one more n square. So 3n square plus, this is 1n and 2n. So 2n plus 1. That's it. Now we got the degree of a polynomial as cube. So the time function is order of n cube. It's order of n cube. Let us see space for this one, space complexity for this one. The variables it is having a, b and c. Yes, a, b and c. N, I, j, k. N, I, j and k. This is a matrix, so n square, n square, n square, and all these are 1, 1, 1. So this is, space is 3n square plus 4. So this is order of n square. Time is order of n cube. Space is order of n square. You can have a look at this whole thing. So that's it. So I have shown you 3 different algorithms taking different amount of time. One was order of n, and n square, and n cube. Next video you can watch the different type of algorithms and also the method how to analyze them.